So let's talk about the 2023 warming from a slightly different angle. This is something that Gavin Schmidt from NASA Goddard Space Flight Center in New York has been keeping up with. And, he's a very good speaker, writes very well, talks very well, and he's been running this story in Real Climate. So it was titled New Journal Nature 2023, was written in May 2024, and I think was updated recently with some other external forcing ideas and so on. This article or this blog or whatever is very nice. It has a lot of references, a lot of ideas. Basically, we have already talked about the record warming of 2023. It's been discussed very extensively in the media, and the talk came up again and again about crossing the 1.5 degree C threshold, and we discussed that in the previous podcast. And my main point was that we don't really know, as Gavin admits in the next article that we will look at. This is Gavin and some co-author. Sorry, suddenly I'm having some frog in my throat. In New York Times as a guest essay, where we say we study climate change, we can't explain what we are seeing. So he's talking about 23-24, and we've already mentioned several ideas. It's obvious that 2023-24 El Nino added to global warming to produce some additional warming in 2023 and 2024, but it's much more than what we would expect just from the superposition of the two. Then we have invoked the water vapor that was thrown up by the Hanga Haipai HDHH, as they called it, that blew up in the tropical Pacific during 2022 and is expected to affect weather and climate for a while. And shipping emissions reductions are mentioned because we came out of 21-22 with COVID lockdowns and so on. And China has been reducing its emissions, aerosols, pretty impressively, and that is also invoked as one of the contributors, because if you reduce pollution emissions or aerosols, you can increase or accelerate the warming temporarily, because you have removed the solar dimming components of the human forcing. Of course, there are a lot of other benefits from reducing pollutions, even if you get a spike in the warming, but that's a separate issue. So let's just read Gavin's essay, because he's very open about what the issues are. And as I have mentioned before, my main issue is that it's not just about focusing on projections for the future, saying, we missed predicting 2023, 2024, and what does it mean for projections, but also to keep an eye on all the disastrous extreme events that happened in 2023 and 2024, in fact, and how many of them, look very carefully at how many of them we predicted, how many of them we predicted well, and among those that were predicted well, how many were actually able to save lives. If you look at the recent floods of Valencia, Spain, with more than 200 people dead and horrific pictures that came out of it, was it predicted? How well was it predicted? And what was missed that the disaster happened without much of disaster management? So it's not just about saying global warming contributed to disasters, but to also keep track of what it means and whether the 2023-24 extreme events are really related to the threshold crossing of 1.5. What does it mean for the future? Because as you keep warming, disasters will keep increasing, but is there really any threshold where a jump happens, or are we just over interpreting the importance of 1.5 and 2 degrees C warmings, keeping in mind that these are not really scientifically derived, they arrived from some other sources, as I've discussed elsewhere. So with that commentary, let's just read what Gavin and his co-author wrote. The Earth has been exceptionally warm of late, with every month from June 2023 until this past September breaking records, so September 2024. It's been considerably hotter even than climate scientists expected. Average temperatures during the past 12 months have been above the goal set by the Paris Climate Agreement to keep the global warming below 1.5 degrees Celsius over pre-industrial levels. Just a detail, 2 degrees C was agreed upon in Paris Agreement. Small island states said no, that's too high, so we put in 1.5 degrees C. We know human activities are largely responsible for the long-term temperature increases, as well as sea level rise, increases in extreme rainfall, and other consequences of a rapidly changing climate, such as food production, vegetation, health, etc. Yet, the unusual jump in global temperatures starting in mid-2023 appears to be higher than our models predicted, even as they generally remain within the expected range. So models don't predict just one thing, they predict an envelope, an expected range, because Mother Nature does something, but she has the potential to do a few things based on where we are starting in mid-2023 and so on and so forth. So graphics of that, nearly every month since June 2023 has been record-breakingly hot. Average global temperature plus 1.8 degrees C above pre-industrial average here in the scale, going from 0.8 to 1.8. In September 2023, the observed temperature was 0.5 degrees C higher than the previous monthly record. So you are looking at projected temperature changes and record-breaking months jumping out above what previous monthly records were. And there is also now projected, so this ends in August or June, yes, maybe September. But you get the idea that basically we haven't been doing very well. It's one thing to say whether CMIP 6 models had predicted this, and then you look at the forcings used in CMIP 6 scenarios that were done before. The simulations were finished in 2020 or so, I suspect, or even before. The report was supposed to be released in 21, got delayed because of COVID, but simulations would have been finished much earlier so that analysis can be done. With all that in mind, while there have been many partial hypotheses, new low sulfur fuel standards for marine shipping, a volcanic eruption in 2022, lower Chinese aerosol emissions, and El Nino perhaps behaving differently than While there have been many partial hypotheses, such as new low sulfur fuel standards for marine shipping, they have this contrail impact, a volcanic eruption in 2022 that I mentioned, Hangatonga, lower Chinese aerosol emissions, and El Nino perhaps behaving differently than in the recent past. 2015-16 was a strong El Nino. 2023-24 was a very strong El Nino. We generally don't have such strong El Ninos together, and whether 2023-24 El Nino also behaved differently. But we remain far from a consensus explanation even more than a year after we first noticed the anomalies. So June 2023 to now, we still don't understand, and that makes us uneasy. Thank you for agreeing, climate scientists. Why is it taking so long for climate scientists to grapple with these questions? It turns out that we do not have systems in place to explore the significance of shorter-term phenomena in the climate in anything approaching real time, but we need them badly. It's now time for government science agencies to provide more timely updates in response to the rapid changes in the climate. Okay, so it's going towards what we have to do and what governments have to do in terms of monitoring and reporting. Weather forecasts are generated regularly. Come rain or come shine. It's English writing. Scientists who do near real-time attribution for extreme weather are also able to react quickly to tease out the effect of global warming on any new event. There are many details there I've discussed elsewhere about the value of attribution. But climate science research is more used to working on approximately 7-year cycles which is the IPCC assessment cycle, to produce reports that summarize the evolving science about the long-term changes in climate. The data that went into the latest round of climate model simulations are based on observations that only run through 2014, and so they don't reflect recent changes such as newer pollution controls, volcanic eruptions, or even the effects of COVID on transportation, shipping, industrial production, air quality. Similarly, the forecasts are stuck with scenarios that were common in the early 2000s. Business and everything else has changed sharply since then. So now we are explaining why the models missed this 2023-24 warming, because we didn't have proper forcing for the models that were doing this. Okay, so 2023 was much hotter than predicted in summary. So if you go from 1980 to 2024, so you have average global temperature again reaching above 1.5 degrees C, above pre-industrial average, and you have the interannual variability as we know, but the trend, especially decade to decade warming, is very clear. And 2023's average temperature of plus 1.4 degrees C exceeded even the high range of prediction. So predicted 2023 temperature ranges based on different models, different scenarios, etc., were in this range, but we just about topped it. Only thing I would say is that these are not actually measurements. These are estimates of measurements blended with models to produce analysis, reanalysis, and so on, which are details. So you have to be just aware of that. Okay, and so you have to worry about what the error could be in these, but it doesn't matter. As a result of all this, a gap has opened up between what the general public and policymakers want and what is available. To fix this, we need to create a better way for climate models to reflect new observations. That means more comprehensive and faster data gathering from satellites, in situ measurements, and economic statistics converted by analysts for the climate and weather models. This needs to be matched by a commitment by the roughly 30 labs around the world that maintain the models of the Earth's climate system, to update their simulations each year to reflect the latest data. So it's still talking about multi-annual predictions or projections out to decades, and not wait for 7-year cycles. But it's not talking about climate predictions at time scales where disasters are happening at hyper-local scales, right? That would be my caveat on this. Some of the information that goes into climate models currently takes years to produce. For instance, while data on greenhouse gas levels and energy from the sun are available within weeks of their observations being taken, emissions of pre-industrial and agricultural air pollutants need to be estimated from economic data, and this can take years to collect and process. So there are again the projection issues for models to be initialized and integrated forward. Scientists should be able to provide good enough estimates of these inputs faster using reasonable assumptions, just as economic analysts frequently update statistics after an initial announcement, such as a quarterly jobs report. Scientists could provide data for industrial emissions of pollutants, the activity of the sun, the impacts of volcanoes, and greenhouse gas levels on 2 or more tracks. An initial estimate using as much data as possible, as much data as is available quickly, and a fully revised estimate later once more data is in. So you provide an initial guess and then you correct it in time. We think that a goal of analyzing data in under 6 months is achievable if the data gathering and climate modeling labs prioritize it. This entails a small shift by the US agencies such as the National Oceanic and Atmospheric Association, that's administration I think, NOAA, and the Department of Energy, and international agencies such as Copernicus, the European Climate Service provider, toward sustained funding instead of one-off research grants. So monitoring means sustained observations and investments. And Copernicus report I already talked about in the 1.5 degree C threshold. Other groups such as weather forecasters would also be able to take advantage of this new data stream. When they are doing seasonal or longer term forecasts, they're also not working from the most up-to-date information and would be able to use them to improve forecasts. So this is the scale I would always talk about, because already everything is happening. So 1.5 degrees C threshold may not mean much unless we can predict them at local scales for every kind of disaster, right? The public would benefit from more definitive knowledge on what is going on too. What resource managers and urban planners could be more confident that they were using the most current scenarios and projections, helping them avoid underestimating or over-preparing for future change. If climate projections were better calibrated to recent changes, we could narrow the likely range of future impacts. So this here, my caveat would be, what is projection here? Is it decadal prediction, or is it still integrating out to 2100 with all kinds of scenarios, knowing that scenario uncertainties dominate the projection uncertainties after about a couple of decades? So what is the time scale at which these water resource managers and so on, urban planners, actually plan? Do they really care about 2100 projections, or are they looking for something shorter time? Some of the unease that people feel about climate change comes from a sense that things are out of our control, that the climate is changing faster than we can adapt to. However, many of the most dire risks lie not with the most likely outcomes, but in the worst case possibilities. For example, the collapse of the West Antarctic ice sheet, which is still a very debated issue, or the drying up of the Amazon and other potential tipping points. I have discussed tipping points elsewhere, so to discuss this in this context, you have to figure out what your own comfort level is with that. But there is a lot we don't know about if and when these tipping points will come to pass. So that's a big caveat. People keep saying we are closer than we realize. What does that mean? We cannot really predict them, so what does it mean, right? So the good news is that climate science could easily become more agile in understanding the rapid changes we are seeing in the real world, incorporating them into our projections of the future, and hopefully reducing that uncertainty. Well, just to end, I will use this from the State of the Climate report that NOAA and other labs together put out every July or so for the previous year. So this is for all the extremes for 2023. So cyclone season runs differently here. But just to see that Canada wildfires, warmest year on record, North America, hurricane season, Hawaii got hit, which is unusual, Eastern North Pacific hurricane season, Hurricane Otis, so you can see all continents and even Antarctica are affected by extremes and the warming in 2023. So attribution is one thing to say whether the record warming created something new or some things were made much worse by the record warming and so on. And the other thing is to just see how the forecasts were on 1 to 3 days, 3 to 10 days, 3 to 10 days, weeks 2 to 4, seasons and so on. El Nino forecast was fantastic and it was very successful, and then came I have a massive headache and some breathing issues, and 2024 started with a forecast of a very strong La Nina, which hasn't materialized. So one big success of El Nino forecast followed by one not so good forecast for La Nina, which again we have to understand what exactly happened there. So we have a lot of issues to worry about, but it's good that we are saying, hey folks, we don't know what just happened, but we'll figure it out. So there will be lots of papers, cottage industry of papers, as the Real Climate article by Gavin says, that there will in fact be many model exercises, data analysis and so on to say why 2023 exceeded all our expectations in terms of the warming. But we are still here in 2024 November, and we don't know what 2025 will look like in terms of the warming, or especially the local disasters in your backyard, what will happen. Unless we get there, we are always struggling with this. So the key question for me in my mind is, Should we invest so many resources on projecting to 2100, or should we realize these issues we have already and start to work with disaster management on days to weeks to months and plan for a decade or two and really assess the cost benefit or cost and benefit ratio of, or just cost benefit analysis of the projections out to 2100, which take up massive resources, okay, financial, computational, human, and so on. So I'll leave it. The idea is not to again get into polemics, but to raise relevant issues, because Gavin comes from one perspective, I come from another perspective, there are other groups which will come from other perspectives, and people, general public, governments are sitting there and saying, but this is what we need, can you give us this? So we're all working towards that, but from different perspectives, so we have to somehow manage the expectations. Okay, I'll leave it here.